Today we will be having a roundtable discussion on p-values. I'm Janet Simon, an assistant professor at Ohio University, and I will be moderating today's discussion. With us today we have Craig Dediger, who is a professor at University of Connecticut, and he serves on multiple editorial boards for journals related to athletic training. Jay Hurdle is a professor at University of Virginia and is the editor-in-chief for the Journal of Athletic Training. We also have Pat McKeon, a professor at Ithaca College, and he serves as one of the editors-in-chief for the International Journal of Athletic Therapy and Training. And lastly, we have Jennifer McKeon, a professor at Ithaca College, who serves as the other editor-in-chief for the International Journal of Athletic Therapy and Training. Welcome, everyone. So today I'd like to kind of just start off with the four of you talking about p-values. So I'd like to just kind of throw it out there. What is a p-value? How should it be interpreted? And potentially, are people misinterpreting p-values?
So from my perspective, a p-value is an estimate of whether the results that you have are coming from different samples or if they're coming from similar samples. And I think that you have to recognize that it's basically based on a simulation that's based on a given set of values that are coming from the samples that are assessed, and that there's an inherent set of assumptions that go into the calculation of the p-value. And unfortunately, there are limitations to that approach, but I think there's limitations to any type of simulation where you're trying to predict what's actually happening. And we certainly know that the biggest limitation is that if you increase the sample size, you can end up lowering the p-value, even though the magnitude of differences get smaller. But ultimately, I think it really is down to, like, if you're comparing for group differences or pre to post differences, are the two sets of scores coming from similar or dissimilar populations?
Well, and I think one of the key things about that, with regards to the p-value, is getting towards the probability that you would find the difference of the means by chance. So when we think about that, how Fisher had originally set up the idea of saying, a p-value of 0.05 indicates a 1 out of 20 chance that you would randomly find these differences in the means in the same way, compared to a 19 out of 20 chance that this is actually what you could potentially find in the population. So when we think about that in terms of how we utilize a p-value, it comes down to the expression of 1 out of how many possibilities. And so when we think about a p-value of 0.05, it's a 1 out of 20 chance. A p-value of 0.01, 1 out of 100 chance that these things are just the differences that we're observing are occurring by random chance.
Can't disagree with any of that. One of the more elegant, simple definitions is a paper from Stern and Smith, and talked about the p as an index measure against a null hypothesis. And the reason I like that is it suggests that the sample is just one piece of information related to a null, and with back to the work of Fisher. I mean, the intent was that folks would repeat investigations several times before one started to perceive a rejection of a null as evidence of truth or proof. And I think we've gone off the rails by looking at a single study and rejecting a null hypothesis as being strong evidence of the rejection of a null.
Great point. Yep.
Follow up on that, Craig. So just because someone has a p-value greater than 0.05, it doesn't necessarily mean that there is no association between, a potential treatment and an outcome of interest. Could you guys maybe elaborate on that? What your thoughts are on that?
Well, I'll lead because I think it'll come right back to one of Jay's points. But the failure to reject a null does, again, it's just a bit of evidence that perhaps the null can't be rejected, but with increasing sample size or narrowing inclusion criteria to lower the variance in the sample, you all of a sudden calculate an F or a T value, then leads to a low P and the null is rejected. And that's where, magnitude of differences or magnitude of association becomes an important part of the conversation.
Yeah, and that's really one of the biggest things, and that really gets at the interpretation of what the p-value is, which is what we've been discussing, and then what the p-value or the p isn't. And so, probably, I know you're saying what you had asked about potential misinterpretations, and I don't know if it's a full-on misinterpretation or not, but that the p-value isn't a measure of magnitude of difference or association. And I think that's the biggest thing. And this isn't a new discussion. This is something that's been going on for at least 15, 20, 25 years. But still, I don't know if we're comfortable as researchers and reviewers just hanging on to that p-value. I don't know if we're comfortable with that misinterpretation, if it's a willful misinterpretation, but we're putting too much importance on the p-value when it really is about a probability. It's about a chance, but it doesn't tell us anything about the importance, the magnitude of the differences or that association. So, yeah, I think that's part of the misinterpretation. Whether it's willful or not, I don't know, or if it's a purposeful misinterpretation.
Mm-hmm. Mm-hmm. And I think one of the things about that again is looking at the p-value as a way of gauging, similar to how we look at numbers needed to treat. And we'd say, 1 out of 5 patients could potentially benefit out of this when we think about a numbers needed to treat based on 5. So if we look at the p-value in that way and say, oh, I got a p-value of 0.2, well, in that case, there's a 1 out of 5 probability that this occurred simply by chance, compared to a p-value of 0.05, a 1 out of 20 probability that this occurred by chance, compared to a 0.005, a 1 out of 200 chance. But it doesn't tell you anything about, as what Jen was saying, about the size of the difference. It simply is providing you with an estimation about the probability that this is either occurring by chance or based on the manipulation of the experiment.
And I think the one thing too is, and this is something we repeat a lot, of saying, well, that this occurred by chance, the results occurred by chance. But really what we're talking about there is the distributions, that the distributions between the two groups are different, or they're probably different, or they're probably the same, or they're probably strongly associated, or they're probably not associated, or not. But it doesn't say, again, how widely separated they are, how big that their difference is. And so it's really just about those distributions and what those distributions now look like, not just the results, but the distribution of those results. And I think that's an important thing to come back and look at, even though it gets into the math of it, which sometimes that people don't like, but actually that and helps with people backing off their interpretation a little bit and not interpreting what their results are, by looking at it a little bit more mathematically of what the meaning of it is.
Yeah, and I think we actually have the opportunity to take a look at some principles of qualitative research where they talk about triangulation, and they talk about trying to draw a conclusion or establishment of a theme based on multiple sources of evidence that support the same conclusion. And I think that's really what we need to do on the quantitative side as well. And that, a p-value is one side of the triangle. But then you also have to take a look at what is the magnitude of difference, whether that be, an effect size, a mean difference, or it could be a correlation coefficient, depending on the specific analysis being done. And then the third part of the triangle is the confidence interval, or that idea that Jen was talking about, the distribution of results. So I think that the p-value is only part of it, and where we got astray was people wanting the p-value to be the only part of it because it was the easiest to understand. If you establish a threshold and it's either above or below it, that's easy to understand, but it actually isn't the full, rich interpretation of the data. I think the other thing I'd like to say, going back to something that Craig said about the idea about repeating a sample, is that inferential statistics are historically have come from the agricultural industry, where you can think about having a big field of lots of plants and you took a sample of some of those plants, and it's a heck of a lot easier to go back to that field and take another sample of plants than it is to do a clinical trial on human beings.
That's true, but unfortunately, just because it's more difficult to do repeats of the same study, it's, Fisher's original intent was to do that, and we've attached this kind of label of significant when we have a low p-value, which implies importance. And how many studies have been published, the null gets rejected and they've been repeated, nobody can seem to come to the same result, but those studies get rejected because they didn't reject the null hypothesis. And ultimately, after years and years, observation, et cetera, have come back full circle to truly challenge the original rejection of the null, to find out either the differences are too small to worry about, or in fact, no real differences exist in the population. It's hard and it's frustrating, but some of the challenges to science is that we read a study, believe the result, and then a few years later it gets challenged, and finally a systematic review and a meta-analysis comes out and comes to a different conclusion, and people just are totally baffled as to why, when the original paper rejected a null hypothesis, reported, quote, significant results, and was published. And of course, one of the challenges in our literature is the bias towards publishing papers where significant differences are reported, and failing to publish high quality research that identifies small or no differences, which are probably more as important to advancing at least patient care as studies where significant differences are reported and often misinterpreted.
And I think the last bias, right on the next thing to jump off of what Craig was saying, is the replicability of the studies too. That you are the first person to publish something, and then once that happens, it becomes old news very, very, very quickly. And so the next person trying to publish that, we already know those answers. We already know that. Somebody already published it. And so actually true replication of previous studies is almost non-existent in a lot of the research in sports medicine.
Oh, it's a point of crisis right now in science too.
And science in general, not even just sports medicine. Yes.
So you guys have talked a little bit about Fisher and kind of some of the historical perspective of p-values. How do you think we've gotten to where he kind of proposed, this level of equals 0.05 type thing to where we are now, where we kind of like hinge everything on that, rejecting the null, and how do you think we kind of got here?
Well, I think it came from, Fisher had originally said, take the approach of whatever you think the probability would be acceptable. Take that level, and it really should be met at an individual case-by-case basis. But then when Pearson and Nyman started to introduce the hypothesis testing idea about developing the threshold and saying, well, we should use p as 0.05 as the cutoff, to now dichotomously say either we have evidence against the alternative hypothesis or evidence against the null. That seems to be where that that idea where we started to train individuals to say either you have evidence for or evidence against your hypothesis. And that even then, when you read what they were saying, the p-value really is still an arbitrarily set parameter associated with the experiment. But the key with them is that it had to be set a priori. And also that the hypotheses had to be set a priori before the experiment was carried out, which is really important. What happens after that, though, is that instead of dealing with experiments where there wasn't sufficient evidence to reject the null hypothesis, I think that's what led us then to start getting into the p-hacking and saying, well, let me figure out ways that I could potentially show that I was right, and or just to not necessarily in a disingenuous way, but just in a way of survival, of saying if I don't publish, I'm going to not be able to sustain my career, or I might lose the funding that I have, or I might lose a variety of things because of the competitive aspects of maintaining novelty.
Yeah, and bouncing off that p-hacking idea, p-hacking in general, probably, like Pat said, it probably is not nefarious in most cases. It's not a purposeful manipulation of the research, but that's what it ultimately can become. And I'm not saying it does become, but it can become, because two things happen. First of all, the whole idea of methodologically, we're supposed to set the p-value a priori. It's supposed to be upfront, and so that we're almost going into the testing blinding, and that's kind of the I don't know, the best interpretation of how you're supposed to go through the methods and designing a study. And so by p-hacking, you're cheating that a little bit by saying, well, we're just going to find out what was significant, and we're going to write about that. But where it really becomes a problem, so there's a little bit from a methodological approach, it's a little problematic. But where it really becomes a problem is in the interpretation, because ultimately you find a result that may or may not be real and may or may not be important. And then you design an interpretation and a discussion around it. And that's where things become hairy, when all of a sudden you change the point of attack of your research and try to create an interpretation that may or may not be true, or may or may not be based on sound science. And so again, not from a nefarious standpoint, people aren't purposefully trying to manipulate the science, but that's ultimately what can happen. And so that's where there's really the danger. And there's the methodological problem, but then there's the actual interpretation problem. And that's where things can really become problematic down the line, as those interpretations get disseminated. And so that's probably the bigger problem, or not the bigger problem, that's probably the broader stretch of the problem of p-hacking, besides just publishing the results that may or may not be significant or true.
For our listeners who may not know what p-hacking is, could one of you explain that really quick?
So p-hacking is doing a series of analyses until you find a p-value less than 0.05, and then you say, aha, that's exactly what I was looking for. But, in reality, that wasn't a priori statistical analysis planned, and the experiment wasn't necessarily set up to actually test the hypothesis that ends up getting reported that way. So it's basically a way of just continuing to change your analysis until you find something where p is less than 0.05, and you can say, aha, there it is. So.
Thank you.
I think another challenge is on the part of the consumer. I mean, statistics is hard. And we tend to teach statistics to folks who are going to use statistics, supply statistics, consume research as a part of their preparation. But I think, a lot of us work with students and probably had this experience. To some degree I did. You're in an intro to stats course and it just seems totally baffling. And you finally figure out something like a t-test and you reject the null hypothesis. And it's like, wow, I've spent a whole semester and I finally understand this. And it's just the tip of the iceberg in terms of truly understanding the probabilities that a null hypothesis can be rejected. And then the next layer has already been introduced, this notion of magnitude of association or difference. I think everybody on this conference right now has spent a long time developing their ideas and philosophies around data management, analyses, and interpretation. Well beyond what we did as the required either undergraduate or graduate simple course in statistics. But for the clinician consumer who's had a course, these are challenging concepts because we'd like it to be nice and clean and simple and know what the correct answer is. And unfortunately, the proof is only going to come with years of repetition and observation to finally confirm a phenomena is real.
Absolutely. And Craig, I completely agree. And I think that putting it on the consumer, especially consumers who don't have the time or haven't had the time or to develop the understanding, it's incumbent on the researchers who are reporting and the reviewers who are reviewing the papers to force the authors to write about something other than a p-value in a way that's clear. So I don't think p-values are ever going to go away just categorically, suddenly, and disappear. And this conversation has been going on for too long that we see that it's not happening. So what we got to do is think about a shift in our presentation, and then as reviewers too, force our authors when they go for the simple approach of going after p-values and everything's different because that one variable p is less than 0.05. Force them to interpret it differently and force them to whether it's a different analysis or a less overinterpretation of the p-value. But I think that's really where we've got to go because we've got to help people who are the consumers and the readers. And so I think you're exactly right as far as it's hard. It's really hard. So I think that we need to do a better job on our side of things as board members, editorial board members, as reviewers, as authors, and then mentors for doc students and master students who are starting to write those of how to do a better job for the consumer.
Can you guys talk a little bit about, because I think there's some value in looking at data for patterns and things like that, and that could turn potentially into p-hacking. And can you guys talk about safe ways to look at data more exploratory that doesn't turn into p-hacking?
I don't. The notion of p-hacking or harking, creating, the hypothesis after the data collected, in some respects, can advance understanding because sometimes questions and answers emerge that we maybe didn't anticipate when we began collecting data. The danger, though, is to p-hack, find a result or an association that meets the criteria of p equals 0.05, write the paper and discuss it like we're wholly confident that the data reflect a true phenomena, rather than publishing it from the standpoint of we've observed something that is of real interest and additional investigation is going to be needed to confirm or refute the observation that we made. And, at some point, some new ideas and some new truths may emerge. In other cases, they may go away. But the danger, again, coming back to the whole issue of a single study and the rejection of a null hypothesis as being evidence of something that's truth, gets us in trouble.
I totally agree with you. So that gets us right into the inductive nature of science, and I think that is a great thing to come back to from the standpoint of the ability to take a series of observations in reality and then look at the potential trends to start to develop a better argument in the end. So just exactly what Craig just described really is the nature of science as we know it now. It just comes down to the transparency of it. So that's where I think as editors, oftentimes we spend a lot of time talking with authors about the exploratory nature of their studies as opposed to the confirmatory nature. Mm-hmm. So where we say, well, you're not trying to confirm a hypothesis here. Potentially the insights that you have actually advance us to a greater extent, whether you've found a level of significance that you were hoping for or not. But in the end, in the discussion, make sure that all of that goes into transparent post hoc discussion. So we're saying we expected this, we didn't find that. How some of the insights that we've gotten out of this now seem to point us in a different direction. And the really nice thing about the inductive side is that inductive reasoning can always be refined by new observations, compared to deductive reasoning, which is oftentimes the idea of the a priori hypothesis that leads to its rejection, can only be falsified and abandoned. And I think that's where we need to help authors, readers, and reviewers to say it's fine to have new insights. You just have to be transparent about where those insights came from.
I think the notion of p-hacking is not necessarily a horrible thing for all the reasons that have already been mentioned. But I think the problem is that the tendency is for all the initial analyses that were done where p was over 0.05 never get reported or acknowledged. So it's like I think that's the problem. And you can even look at something like regression analyses as being a form of p-hacking, right? Because what you're really trying to do is to try different combinations of predictor variables until you get the smallest reports the greatest amount of variance. Now, ideally, you do that in a systematic way that is laid out ahead of time to say these are the steps that we're going to follow. So this concept of p-hacking isn't necessarily new, and I think it's only going to get more prevalent as you get into larger and larger data sets, and we start looking at like principles of machine learning, which are essentially looking for relationships that we didn't even expect necessarily, or didn't even know we should test or have an idea to test. And again, I'll go back to what Craig said, that I think that's actually a good thing, is that it can be hypothesis generating.
So I'd like to spend the last 5 or so minutes talking about how do we move forward. Are there other options to include in addition to p-values? What are your thoughts on how do we move research and presenting results and doing analyses forward?
I think the answers lie in the nature of the questions and the data. I think there's some guidance in some of the work done in studies of diagnostic accuracy, because often you have a dichotomous outcome, and it kind of lends itself to at least modified Bayesian reasoning. And too often in our interventions and prevention work, we look at changes in levels of impairment or function rather than taking a more dichotomous approach. Did the patient achieve or fail to achieve the goals that were set forth at the beginning of their treatment? You start looking at odds of achieving an outcome with competing interventions, and I think it helps us become a little bit more patient-centered in our research, which may be more informative of both the patients and the providers for the condition of interest. when you don't have the ability to define dichotomous outcomes, confidence intervals are helpful because at least they're in the magnitude of the measure of interest. My personal bias now is that effect sizes should be reported with great caution. I've got a paper on my desk to review that reports effect size and fails to report confidence intervals and really address the magnitude of the differences that were observed. And a study that has fairly narrow criteria for inclusion often has a fairly small variance between the participants, which automatically inflates an effect size. And then, the last problem is, what does an effect size mean? An effect size of 1, so what? It's a change twice the standard deviation, but that standard deviation is artificially small. We're inflating our observation of effect. So, I think it's kind of a 3 layers start to work at the level of what outcome is important and what are the odds or probability of achieving that with competing interventions. Short of that, fully interpreted confidence intervals in the magnitude of the measure that was acquired in the investigation.
Yeah, I think that there needs to be a realization that there are multiple correct ways to do any statistical analysis, and that there are also wrong ways. So, I kind of look at this as saying, like, what's the best way to, drive from point A to point B? Unless there's only a single road that goes there, there's probably some people say, oh, you cut over this way, and then that's going to shave some time off. Other people say, oh, no, you got to go this way, and they're both correct. Like, they'll both get you to the end point successfully. And I think that we need to have some realization when it comes to statistical analysis that there isn't just one way to correctly analyze and interpret a set of data, and that makes people uncomfortable. And I think that's the same reason why people like p-values, is because they like that preset threshold to make it very simple. But the problem is that it isn't simple, and that there is uncertainty that's going to be there. And I think there would be a lot of benefit if we taught statistics in that way, in terms of recognizing the uncertainties as opposed to looking for the definitive conclusion. In terms of the Bayesian approach, looking at dichotomous outcomes and trying to predict the likelihood of success or failure in any given individual, I think that's fantastic. I think the challenge, as Craig mentioned, is determining what is the threshold for those dichotomous outcomes. And it's much easier if you're talking about a diagnostic study or a prevention study where something either happened or it didn't. I think it's harder when you get to treatment efficacy, and most of the methods for determining those thresholds are actually based on the same statistical premises as the p-value that we're kind of criticizing. So, I think that there is some challenges there as well in terms of deciding what those thresholds are. But again, I think if they're done in a thoughtful manner and can be justified, that works.
Yeah, I agree with all the comments, Jay and Craig. And I think one of the biggest things that we can do is be careful about our interpretations of the p-values, and of any stats that we're running. So anything that we're coming out with, what are we actually interpreting from that? For example, because Jay, you just mentioned treatment studies and the effect of a treatment, but in treatment studies, as we're asked to critique the methods, one of the things that's asked about is baseline characteristics, and that a way to determine that groups are similar at baseline, oftentimes what's reported is through a t-test or similar parametric or inferential statistic of were they different or were they not different, and report the p-value. And if the p-value is above 0.05, then the groups weren't different at baseline. But the interpretation of that really doesn't even make sense. And this is an argument going all the way back to Altman in the 80s of, first of all, you're testing that something occurred by chance, and through that the groups are split up and that their characteristics are based on chance. But you already knew that because through the randomization process, the groups were put together by chance. So there was kind of the absurdity of it that Altman had argued against. But up from a more method and kind of more methods-based approach and statistical-based approach, that really, again, coming back to the magnitude of difference, if you have some characteristic in group 1, the characteristic is X, and in group 2, the characteristic is Y, and those are significantly different, just from a p-value standpoint, we still don't get at whether that magnitude of the difference between the groups is substantial or not. And to overinterpret it and say, oh, they're different, so that must be a confounding factor, is a dangerous approach. Or that they're not different, so there were no confounding factors in the end result, is a dangerous approach too. So not saying that there's you should never do that, but searching for confounding factors and the magnitude of that confounding factor just by using a t-test or just by looking at the p-value is not enough, because it doesn't tell us how big of a confounding factor it is, just that it might be. And so again, it's an approach that we just need to really be careful about the interpretations of different statistical tests, and try to really tease out what we're actually looking for and what they actually mean, and not just jump to conclusions about them.
Yeah, if I can just follow up on that. So in March 2019, the journal called The American Statistician put out a supplement all about p-values, and one of the articles in there by Wasserstein et al. Is called "Moving to a World Beyond P less than 0.05," and they recommend in that paper the following approach to statistics, which are to accept uncertainty and be thoughtful, open, and modest when you're presenting your results. And I think that those things really follow up on what Jen just said there, that don't look for a single finding to represent a paradigm shift in whatever field you're studying, and recognize that what you really need is repeatability of results, and that each study essentially adds modestly to the overall understanding of the field.
I like the simplicity of that. That was great.
I like that a lot too. Well, and building on that though too, just as finishing up, as we're finishing up, I think we are talking about a change in culture in many ways. And I think one of the things about the p-value especially is it represents the culture of trying to find success based on an individual contribution. Just as what Jay was saying, what Craig has said, and what Jen has said too. And I think, coming back to science as a human endeavor, just as what Jay finished up with the atom notion as well, is it comes down to the modesty component, which is really a key component about that we're all in the same game. We should be working towards it together, as opposed to vying for who gets there first. And the other part about that is when we think about how we teach research, oftentimes we teach our students research at the level of generation, where you are going to conduct a study and work towards developing a unique contribution to the body of the literature that exists. But I think we need to shift that and say maybe we need to first move towards the notion of not only helping them to appreciate what research is, but the next logical step then is, let's try to reproduce what's out there already, and let's try to replicate, if possible, some of the experiments or the observational studies that have been done, so that you can better appreciate the process, but also we can help to refine some of the probability associated with the hypotheses that we're trying to either develop and generate or confirm and defend.
Thank you all for being here today. The discussion was great. So just thank you all for joining me. All right, I'd like to thank everyone for being part of this roundtable discussion. I think it was a great discussion that everyone had. If you have any questions for our panelists today, please feel free to reach out to any of them via email.